We're going to begin learning about Kotlin by learning about variables, pretty much the most basic part of any language. So I'm going to go out to again, play.kotlinlang.org, and we'll use the little web-based editor. So variables are declared, and if you wonder why am I typing out some of what I'm saying, it's because since I'm recording these videos and I want to take the code that I write here and make it available to you, so I'm going to make some notes along the way. So variables are declared with the var keyword, and the basic pattern is var variable name, colon, and the type. So for example, we could do var intro, data type string. And what have we done? Well, we've created a new variable and its data type is string. So assignment is done with equal sign. So what I mean by that is what you'd expect pretty much. So intro equals hello world. So now I've created a new variable called intro. It's a data type string. I've assigned text to it. And we can print to console with print line. And what I mean by that is, and I think we saw that earlier, but if I do print line and then intro, and now if I run this little application, what we'll see is hello world will print out. So it prints out the content of this variable. So very straightforward. One of the things though that you'll see, you'll notice we did it in 2 lines. We declared a variable, we assigned a value. What you'll find as you write a lot of code is that most of the time when you declare a variable, you already know what the initial value is, so we can do that. So we can initialize it with data. So I could say var, it's called another intro. It's a data type string, and then I can immediately say equals howdy folks. So now if I do print line, another intro, we print out hello world, howdy folks. So variables work pretty much like they do in, or at least this part at the most basic level, like any other type. There's lots of different data types. And I'll tell you what, I'm going to put a bunch of spaces down here. Maybe I won't have to scroll quite as much. So for example, we could do var, we'll use kind of generic names here, my string. So we have a string, which we've already seen. For numbers, a lot of times we'll use int. So that's an integer. An integer is roughly plus minus 2 million, somewhere in that ballpark. If you needed a very long, and it's a whole number, integer is a whole number. If we needed a really big whole number, you could do a long. And if you need a short number, something smaller, like you don't need to use so much memory because you're going to be nowhere near 2 million, you could also do my short. So you got long and short. Short is a, I keep mistyping, there we go. Short is, it's 2 bytes, so it's plus minus 32,000 roughly. If you need floating point, they have those. So you have a double, and we got var my float, and you have a float. And another, probably the last one that's most common would be, again, sorry about that, just keep scrolling off, a Boolean, which would be, of course, true, false. And so you may say, well, and there's lots of others. So the question comes in is, well, how do you find out what the others are? Let me copy the URL here. I mentioned in an earlier video, kotlinlang.org. You will certainly spend time on that site during the course, and I already have it open here. So if you got here, you'll see integer types, and it also gives you the values. Generally speaking, you're going to end up always using ints, but if you need something longer or you know the value will always be much smaller. But truthfully, you're almost always just going to use int. Same thing if we scroll down here a little bit, floating points. You got doubles and floats. So again, float's a little bit smaller, double's a little bit bigger. You can also do char if you ever need it. You probably won't very often, but again, know it's out there. A char would be a single character, and it is Unicode. And then a Boolean, of course, is true, false. So these are the basic data types. And there's certainly more that you'll see throughout the course, but these are the basics that you need to know right off the bat. Before I do too much more about variables, let's just talk about math real quick. So math, for the most part, is going to work exactly like what you expect. And so what do I mean by that? So we could go through and say, we declare a variable there called myInt, so let's give it a value. So myInt equals 1 plus 1. So addition's a plus sign, subtraction is a minus sign, multiplication, right, is a star, we do the slash, for division, all the basic stuff you'd expect. So I can do print line myInt. So what's that going to give us? Well, let's see, 1 plus 1 minus 5 times 10 divided by 2. Oh, but don't forget orders of operation. Right, you remember from basic algebra. So I'd actually do this part first. So you get 50 divided by 2 is 25. And then we'd have 1 plus 1 plus 25, or minus 25. So it's going to be what? Minus 23, I believe. There we go, minus 23. So again, math works like you want. There's other stuff out there, exponents and things. Again, you can look that up on kotlinlang.org. So there's math. Oh, actually, you know what? Let's talk a little bit more about math. So let's go back here. Let's go to myInt. I'm going to reassign it to a new value, equals 11 divided by 3. This is one of those things that if you're going to do much math in any language, there's just a few basic things you need to understand, and one of them is around division, or anytime that you have a whole number that came from a potential floating point number. What's it going to have? Does it round? Does it truncate? Etc. So 11 divided by 3 is going to give us a decimal, but I'm assigning it to an integer, and then we're printing it out. So when we run this, we get 3. So what you'll notice here is it truncated it off. And we can see that by saying my double equals, and we'll see a little bit later why I'm adding the 0, but I'm going ahead and letting the compiler know these are floats. We'll talk about this in a little bit. And if I print my double out, so same math here, but you see it's, oops, let's do print lines. Sorry about that. So what print does is it prints it without kicking down to a new line. So we printed 3 and 3.666. Let's do it again. So you get 3 and 3.666. So it's important to note that when I did this division and assigned it the number 3.66666 and assigned it to an integer, it truncated it. It didn't round it off, didn't round it up, it truncated it, rounded down, always round down. So over here though, we did it. These are actual doubles, so it gives me floating point precision, and I get 3.66666. So again, just something important to know. So I said just a minute ago, we'll talk about this a little bit. So what's going on here, the reason I had to do this is I want to be explicit to let Kotlin know that these are floating points as opposed to whole number. Kotlin, like most modern languages, Kotlin really doesn't like when you mix when you mix together different data types. It really wants them to be the same. So for example, if I said var added numbers is a data type int, and let's say is equal to myInt, And let's add plus my double. Right, so right now my int is 3, my double is 3.666666, right? And then let's do print line added numbers. Okay, so when I run this, type mismatch. So what just happened? Well, I have an integer and a double, and I'm trying to assign it to an integer. Kotlin really doesn't like that. It will give you compile errors when you try to mix stuff up. So a few different ways to tackle this. In this case, probably the easiest way would be to convert this double into an integer. And this is a good time then to talk about the data types that we've used so far. So in a lot of languages, your integers and doubles, those are base data types, and meaning they're exactly what they are. So like an integer would be 4 bytes, and it's going to read those 4 bytes out of memory as a number. But in Kotlin, there's no base types at all. Everything is an object. So when I declare an int or a double or a short or whatever, it's actually an object. And because it's an object, it has all kinds of additional features that they've added to it. So for example, all the number types have this function called to, and then turn it to another data type. So if I say toInt, now we've taken my int, taken my double, I've converted it to an int, we add them together, and we can print it out. And now it works just fine. So we get 6. Why did we get 6? Well, my int's 3, my double's 3.6666, turned it to int, remember it truncates, so it turns it into 3, adds those 2, we get 6. The thing to kind of be a little careful about, let's go back to var added numbers. And let's this time say it's a double equals my int plus my double. And you might expect, based on what you just saw, and I said it doesn't like to mix data types, you'd think, oh, well, this is going to error out also. But on this one, it does not. Okay, so there are some cases where you can mix data types and it will implicitly convert the data type. And in this case, because I'm going from lower precision to higher precision, it will automatically turn int into a double and then add them together. So there are a few cases like this where Kotlin will do it. I would not recommend that you ever rely on that. There's a good reason why modern languages don't like mixing data types and don't like implicitly converting things. So it just leads to defects, it leads to bugs. Sometimes it leads to very difficult to find bugs. So you should always try to do your conversions into the right data types, combine them together. Now when you're going from less to more precision, this will work, but I wouldn't recommend it. Okay, so next thing I want to talk about is let's go back to the basic declaration again. And just one thing I want to mention. I'm trying to think how I want to describe this. Let's do this. Sorry, I'm trying to keep track of my notes here as I cover this and remember what I wanted to cover in what order. So let's do this. Let's jump to string concatenation. So string concatenation, something comes up in a lot of programs. So let's declare a new variable called var first name. It's going to be a string, and then let's give it an initial value. We'll use my name. So if I say, and let's say I wanted to greet me. So one way to do it is I could say print line hello, add a space, plus first name. And if I run this, it'll give me hello, Michael. So I had to put space in there, right? String concatenation, we're adding this hello, then we're appending to that string another string with the name Michael. However, nobody does this. There's a feature built in something similar in most modern languages. In Kotlin, they call it string templates. But this would be the way you'd want to do it. It's the way everybody does it. And it ends up, as you get more complicated strings, where you're concatenating a lot of different stuff, this method ends up just being a lot easier to read and understand. So you can see here it's print line hello, and then when I put a $sign here, that tells Kotlin that what's going to follow is a variable. So these two lines, I mean, functionally they do exactly the same thing. There it goes. Prints them both out. But it's definitely the way you want to do it. So if, and to give you an idea of how this gets a little bit easier, or a little bit easier to read, we could say hello, first name, your lucky number is, and then maybe have another name, $, added numbers from above. So we run this now, we'll see, somewhere I mistyped something, first name, did I mistype added numbers? Probably misspelled it, let's see. Unresolved. Oh, mistyped print line. And so, another side note here. When I'm typing stuff out, as you've seen already, I'm having to correct myself constantly, mistype things all the time, and I'm leaving all that in the video. One of the things that I love about software development, the reason I've been doing this for most of my life at this point, going on, 28 years, something like that, something ridiculous, that I've been earning my living writing software. One of the things that's great about it is you can screw up 1,000 times. You just got to be right at the end. And I just love that, right? So you just feel free to go through, you make mistakes, you correct your mistakes. It only matters if you're right at the end. Okay, so there we go. I should have read the error message, it would have been more clear. So you can see, hello, Michael, your lucky number is 6.66666. Ooh, I'm glad it's not truncated to 3 decimals, or just 3 digits, huh? But as you can see, this would have been a lot more complicated, right? If I had tried to, do it the old-fashioned way, we would have ended up with something like this. And it just doesn't take long until this gets very unreadable. Okay, so there's also some other things we can do with these. Put $signs back in here. So the whole 666 thing, I'm not crazy about that. So let's do this. You can also include things that are a little bit more complicated. So let's say what I really wanted to do was to alter added numbers. So I could do added numbers plus 2. And so now what's going to happen is it will add this all together, and in this case it's still going to come back as we're a double right now, but it will convert the double automatically to a string. So in essence what it's going to do is call the toString method. Oh, okay, autocorrect. The web-based one, the auto, there it goes. Sometimes the auto stuff doesn't show up for me, but there's a toString just like a toInt. And now it will execute this, add it together, turn it into string, and then print that out. So there we go. Now it's 8.66666. Okay, so string concatenation. Let's move on. So the next thing let's talk about is mutability. So far, everything we've talked about, you should be familiar with. It should look a whole lot like some other language that you've already learned. So you should be able to pick it up very, very quickly. Anything that I'm not explicitly covering, you will be able to go out into someplace like kotlinlang.org or just Google and get the answer to it. Very easy. Mutability and non-mutability may not be something you've seen before, or at least not very extensive. So there's actually two different kinds of variables, right? There are mutable, and mutable just means you can change it. So a variable is var, like we've been using, right? Actually, since that has a meaning, I'll do that. And then we also have immutable variables, and we declare those with a val. So what do I mean by that? Okay, so let's create a new variable. So if I did it before, let's have the last name. So I could say var last name string equals, we'll use my last name, right? And I could then change it. Last name equals Jones. And right now this code will run just fine. All right, it's printed out. Okay. So if I run this, the code runs just fine, right? So it prints out Jones, just like we'd expect. So it was originally Thornton, we changed it to Jones, printed out Jones. But we can also declare them as val. And the difference is on val is immutable, meaning you can't change it. So when we try to run the program now, I get a compile error, val cannot be reassigned. So go back, works just fine. So a val, it really works just like a var, except you can't change the value. And you may say, well, in other languages, you have const, right, for a constant. And that's true. And this is very similar to a constant. But the difference is more about attitude, I think, than technology in this case. So in most languages, let's say Java, right, you declare variables all the time, and variables can be changed. Unless you put some kind of extra, modifier on it. Const, it's possible. Or, in Java, a lot of times you'd use static final, for example, when you declare the variable, so that you can't change it. But for the most part, people only use those with things that are true constants, like you may, define pi, right, as a constant. But for the most part, all the variables you create are variable; they can change. And what a lot of modern languages are doing, and you see this in Kotlin, you also see it in in Swift, is another language that makes heavy use of this. But the idea is that most of the time when you create variables, if you really look back over your code, particularly when you're out coding in a professional environment, what you'll see is that a lot of times your variables get created and assigned data, and then they never change. I don't have any idea of what percentage it is, but it's a lot. So if we know the data is never going to change, then let's create the variable in a way that enforces that. So one, it makes it easier from a performance standpoint and a memory usage standpoint. It's just much more efficient for the application if it knows this data is never ever going to change. And then the other one is from a stability and quality of code point of view. When you know the value is not going to change, by declaring it as val, when you write that code, well, if you go back to make changes to that code in 6 months, somebody might inadvertently maybe make a change to that variable and change the data when the original code is never expecting that to happen, right? So it can introduce bugs and defects. So the idea is let's just make them vals and not change them. What I'm going to ask so that you get used to this concept is unless you know for certain a variable could possibly change values, you should declare it as a val. And if later you find out you were wrong and it should have been a var, because you need to change the value, then it's easy. Go back to the original declaration, change the L to an R, and you're good to go. But I want you to get in the habit of using vals a lot more and start to see that just how often you never have to change the value of a variable. So, mutable and immutable might be a new concept. Another new concept, or possibly a new concept, is type inference. So Kotlin is, we talked before that Kotlin doesn't like to mix data types. It is a very strongly typed language, right? And you'll hear languages strongly or not strongly typed languages. And it means kind of how easy is it to change one variable from one type to another type and kind of mix them up. Some languages actually go all the way to the point that you don't have different data types. There's only one data type. Most modern languages these days don't do that. There are exceptions, certainly, particularly when you get into like scripting languages, Lua, JavaScript, etc. You can create those with untyped variables, meaning just every variable, it just holds data of any sort, and then the program at runtime tries to figure out what you mean by your data. But as you can imagine, it leads to a lot of problems. So, not all, but many professional developers really prefer strongly typed languages, particularly when you get to large, complex software. So Kotlin is extremely picky about you declaring the data type and knowing exactly what the data type is at all times. So because of that, you can kind of do something really interesting. So we can go through here and I can say var, let's do middle name. And my middle name we'll use Scott. So what did I do? What's the data type? Is it like a magic one? Could it be anything? Nope. As far as Kotlin is concerned, this line of code above is identical to this. These are, for all practical purposes, the exact same line of code. So what happens here is when I declare middle name, I assign it a default value, and the default value is a string. There's no question in anybody's mind, including the compiler, that that is a string. Well, if I'm declaring a variable and I'm assigning a string to it, then this variable clearly has to be a string. So the compiler will infer the data type from the code that you've given it. So same thing, if I went through here and did a number, I could say, let's do var some int equals 9. So what have I done? I've created a new variable called some int. This is now not as clear, but this is an integer. And you may say, well, that could be a long, it could be a short, right? And you're right, it could be. But since an integer is a whole number plus minus 2 million, it uses this as the default. But let's say you wanted to declare some int and I wanted to assign the value 9, but it's a var, it could change in the future. And I wanted to make sure it's a long. I could add L and implicit and tell the compiler that that 9 is a long. So when you do it, make that assignment. We could also do, but let's go back to int. So this is normally what you'd see, right? And let's go back to this one. Let's do some double. And if I add a decimal, in this case I did 0, but it could be point anything. It will see this number. It will assume it is a double, and this variable now will be a double. So type inferences. Use inference. Most developers will. So use inference. Most of the time, the developers, if I could type it, this is what they're going to do. And so you may say, oh, so much, your code's more readable if you declare your data types all the time. I don't disagree, but that's just not what people do. They rely on type inference. And anytime you sit down and start working in a language, it is important to kind of start to adopt the styles that you see that other developers are using in that language. And it's not to say that they're always right, and sometimes you can influence the styles and start changing them. But it becomes important because one, you're going to have to look at other people's code, and they're also going to have to look at yours. So by doing things in a similar way, it just makes it easier on everybody. And in Kotlin code, for the most part, when possible, people do not declare the data types. They use type inference. So it's very, very common. All right, moving on. So I give ourselves some more room. And that's next. Check my notes here. Oh, okay. So here's the one, another concept that might be new to you. Optionals. So let's go back to, I'm going to comment this out because we'll use middle name again. So let's go back to this. Let's do var middle name. So it's a var, I can change it. And let's make it equal to Scott, just like we did up above, right? Darn it, come on. The autocorrect is really odd on this editor. Anytime I type in literals, it wants to turn it into some kind of code, and it seems to just almost randomly guess something. Let's do print line. Okay, so far so good. It does exactly what we expect it to be, right? And we know that we can change it. It's a var. But what if, for some reason in my code, I need to change this variable to a null? So you should be familiar with the concept of null. Some languages, instead of null, use the word nil. For practical purposes, it all means the same thing. It means there's no data there, right? And it doesn't, I mean, literally, there's nothing, right? So in this case, I changed it to, and this is, certainly you can do this in most languages. I think a lot of you guys have used Java before, and you can assign things to null. And when I go to print this out now, look what's going to happen. I'm going to get a compile error. And it says, hold on. You can't assign null to this variable. Well, null does exist, right? So why not? Well, the reason is that there's two different kinds of, or two large classifications of objects in Kotlin. And it's optionals or not optional. So what does that mean? And to explain it, it might be easier just to show it and then talk about it. So let's go make this line of code work first. So if I run this now, it'll work just fine. And what's going to happen here, I'll talk about why it prints out the word null here in a little bit later. But what's happened here is I've declared a new variable, middle name. It's a string question mark. And then I assigned it data Scott. Then I reassigned it to null. And now I have a variable called middle name, and its value is null, nothing. If it is possible that a variable could have a value of null, you must explicitly note that when you declare the variable. All right, so I'll say that again. If there is ever any possibility that a variable could have a null, you must explicitly define that in the declaration. And we do that by adding a question mark to the end of the name of the object. Right, so in this case, remember I said all data types are objects. Now we'll create our own objects and see more in the future. But string is an object, and if it could hold a null, I need to give it a question mark. So why? Why is this? Why? This is really, it's a strange concept. Sometimes it takes people a little while to get their heads wrapped around it, but you definitely want to, because this is the future. This is the way Kotlin works. If you ever go do iOS development, it's the way Swift works. The concept of optionals in the latest version of Java, or maybe the latest two versions, but anyway, recently, Java has introduced the concept of nullable and non-nullable data types. So it's becoming very common. So why? So before I get explaining a little bit more how this works, I'm going to just talk about why we do this. And sometimes if you Google the $1 billion mistake or $1 billion bug or $1 billion defect, what people were referring to with that is a null reference pointer. So what happens in your code is that you've written code and it uses a variable, and for some reason that variable has null. And when you try to execute your code with a variable that has a null value, your program crashes. Depending on how much coding you've written, you have probably already seen this in your own program before. If you have never seen a null reference pointer in your own program, then you just simply have not programmed nearly enough yet, because it is super common. Just to give you an example, I'm recording this video on a Wednesday. On Monday of this week, was investigating a crash in production with one of the applications, and it was an Android application written in this case, it was written in Java actually. And it was crashing at runtime. It had to do with when some data was being pulled back from a geolocation, making a GPS call, and the value came back as null, but the developer didn't check to see if the value was null or not. They just kind of assumed that we'd have data in this variable. And there was no data, so the program would crash when you try to access it. This is super common. So to get around this, what modern languages are doing now is saying, look, you need to be extremely clear. And not only do you have to be clear, what you're going to see here in a minute is we're going to kind of force you to always check for nulls. So by setting this here with a question mark, we're letting the compiler know that this could possibly be null, and that's going to have some other implications as we go through here. So let's let's add some stuff here. So let's try to see if we can understand this a little bit. So I'm going to create another variable. When you're just doing sample code to explain things, it's hard to come up with names. So we'll call this name middle. And let's say I'm going to say name middle, it's a string, and is equal to middle name. Right, so I have a variable up here. It is an optional string. I've got another variable that's a string, a non-optional string. And I'm going to assign, I'm going to create it and initialize it with the optional string that I created up here. Right? Makes sense? So when I run this right now, we're going to get an error. So what I'm showing here, or what I wanted to talk about, is you can't really mix optionals and non-optional variables. Because they are fundamentally a different thing. So the easiest way to think about this is that a non-optional variable, it's an object just like you normally expect it, other than not being allowed to have null. When you create an optional, that basically puts a wrapper around your object. And sometimes you hear it referred to as a wrapper, sometimes you hear it as a box. So it means all the same thing. But what happens is you get this wrapper around the object, and then that wrapper object will note, is it nil or not? Right, so the wrapper object has things says this is null, or the wrapper says, it's not null. So it's fundamentally a different thing. So I can't assign one to the other, right? We have to, and you'll see here in a minute how we would do this. We're going to make some changes, but that's the basic idea. So let's take a look at that. So to see this a little bit easier, let's use a number. Denominator. And I'm going to make this an int, and let's assign it 4. Good number as any. So I have an optional int of denominator, and it has a value of 4. And then let's create another one called numerator, and let's give it the value, let's do 10. Okay, so I've got two variables. Both of them are value types, meaning I can't alter them. And the first one is an optional int. The second one is a non-optional int. So if I tried to just use it, if I tried to say val answer equals numerator divided by, see the context, there we go, denominator. If I tried to just do this, we're going to see if we get an error. So what's happening here is, again, I'm mixing completely different object types, right? Numerator is an int, denominator is an optional int. It's not going to allow me to do this. One, because I'm mixing data types, but also because denominator, it might be null, right? So I don't want to do that. So there's a few different ways of dealing with it. Probably the easiest to understand is you can just check. And you may have seen code like this in like Java code or C code, where you do something like, and we'll talk about if statements more, but if statements are so similar to every other language you've ever used that there's not much to say. So I think you'll be able to follow the code without any problems. So if I could say, if denominator equals null, print line, answer is undefined. Else, scroll up to give us some more room. Answer equals numerator divided by denominator, print line, answer is $, answer. Okay, so right now, both have values. It's not null, right? It's 4. So when I run the code, oh, and I can't type, geez. There we go. So when I run the code now, we get answers 2, right? So we have 10 divided by 4, which would be 2 point something, truncates it to 2. What happened here? Well, is denominator null? If it is, we print it out undefined, otherwise we run this code. Well, it's not null. We could make it null. Let's go up here and see. If I said null, it should print out answer is undefined. And that's what we get, answers undefined. So it should be pretty clear what we're doing. What we're doing here, we're checking it. The real thing that would seem confusing is if you remember just a minute ago, I tried to run this line of code and it wouldn't compile. So let's go move it back up here again. I want to run this, I get a compilation error, type mismatch. But it's the exact same line of code that's down here, there's no compilation error. Why not? So this is another case, just one brief side note, scoping works pretty much like every other language in the world. Val answer and is declared within main. This val is inside this else block, so any variable declared in here is local only to the block it's declared in. Again, this should be very similar to things you already know, being juniors and seniors. So why didn't this work? But it did down here. So this is another one of those things of, because we have to be so explicit about our data types and whether something can contain null or not, Kotlin is able to intelligently unwrap or unbox and convert our optionals into data if it knows data is there. So in this case in my code, what's happened is Kotlin looks at it and the compiler looks at it and says, we just checked to see if this is null. So in this block, we absolutely know denominator is not null. Since we know that, this denominator variable is actually a different variable. This isn't unwrapped. So this isn't a optional int. This is now an int inside here. So pausing for a second, dramatic pause, just so you can wrap your head around this a little bit. Right? The compiler figured out what was going on, and it's allowing you to use the unwrapped version because it knows you have a value. So this kind of pattern comes up all the time. This is a little bit wordy, truthfully. So you'll see some other things that people do that's actually a little bit more common. So we go down here. Let's take a look. A little bit more common way was that when you get to the point in your code that you need to use an optional, you can go ahead and check for it. So you could say create a new variable and do the conversion. So I could say val, we'll call it d, right, equals if denominator is not equal to null, else 1. So what I did here was, if you run into a case in your code where I want to use the value, if it is a null value, I want to use some default. And this comes up, again, this is, kind of comes up fairly common. It's not hard to imagine some cases where this might be. So you can do it this way, one line of code. So value d, so I created a new variable, an immutable variable called d. And it's going to be assigned, if the denominator is not null, we're going to assign it denominator, but it will be the unwrapped, not the optional int, but the actual int. So now d will be an int. Else, assign it 1. Now these two data types have to be the same. So this optional int, and this has to, which will turn into an int, then this has to be an int. I couldn't do like, that, right? But one line of code. So hopefully you guys can follow that. Right? So what's happened is I've created a new variable and I've unwrapped it. So now I'm free to do something like, I haven't done answer anywhere yet, right? Good. Val answer equals d divided by, numerator divided by d. And now this is a perfectly valid line of code. And I'm not printing it out, but right, compiles it ran just fine. This is so common. This happens so often that there's actually a shortcut. And it's called the Elvis operator. And I keep meaning to look up where that name came from, and I keep forgetting to look it up. So I'll leave that as an exercise to you if you care. But it's called the Elvis operator for some reason. And the way that works is we could say val d equals denominator So this line of code is identical to this line of code. So it's just kind of a shortcut. So we create a new variable called D, and it's going to get the unwrapped version of denominator, or it's going to get a default value of 1. And so now the code runs exactly like it did before. There's one more way to do this that I'm not going to, well, I'm going to show you, and then we'll talk about why I'm going to say don't do it. So let's create a new variable. I'll call it val answer. Let's just to keep things clear. Call that answer 2. I'll call this an answer 3. So remember the line of code that does not work because we haven't unwrapped anything. Come on, pop up, new NUM. There we go. So what you'll find is when you're actually using Android Studio, the editor much more responsive than the web-based one. So here we know this line of code does not work, right? So if I go to run this, we're going to get a compile error. This is, right, I'm trying to use something that could have a null value. Does not like that. I'm trying to mix these two. If these were both, but just by the way, if these were both optionals, it would be fine, because if one of these was null, then it's not going to execute and this would get null. But because this one is non-optional, it wants to treat the whole thing as non-optional. Well, what you could do is this. If we don't want to convert it, you can just do that. So this is just a little shortcut. Bang, bang. People don't call it an exclamation point. In coding, these tend to be called bangs. But if you do a double bang at the end of an optional variable name, it tells the compiler, don't worry about it. Just treat it like it has data. So what that means is if denominator has a value, and in our case it has a value, 4, it runs just fine. So I can go down here and I can say print line answer 3. Right? So if we run the code now, down at the end we'll get answer 3. It's just fine. Right? And if I come up here and change this to null, we get a runtime exception. Null pointer exception, if you remember, that I mentioned. That $1 billion mistake. So it is something that's in the language. It's something that occasionally will come up, but it really shouldn't. Anytime you think you need to explicitly dereference it, you're probably wrong. Not always, but probably. It's just dangerous, and it's going to lead to some problems in the future. Take the time, write the extra code, do the checks, do the conversions. One other just side note, you'll notice it says java.line. I thought we were using Kotlin. Just the way the compiler works, it compiles down. There's a lot of what Kotlin uses is also still based on Java, and compiles it down and very similar. So you'll see, and you actually can use Java right in your Kotlin code. So let's go back and fix this. So it doesn't happen. So anyway, bad idea. Don't do it. Okay, a couple of things I want to cover just real quickly. Arrays and lists. So, sometimes you need to have arrays. And we'll see this more when we actually start. We'll talk about arrays and lists and collections and things when we actually start doing more Android code. But just to give you a basic idea. So we have an idea, we can do array, and I can do to create an array, it's of data type array. So I could say an array of, and now what I've done is I've created an integer array called int array, and it's a fixed size of 4. I can't change the size. And it's got 4 values, 1, 2, 3, and 4. Let's make a middle one, I could say string array. Array of. So what I've done here is I've created a new variable called string array. I can't make changes to it. and it is an array of, but this time I want it to be string, so I need to explicit. If you don't say anything, it assumes integer. But if you want to declare the data type, just in brackets, I need to call out, here's the data type. You may be familiar with this same concept in Java. So it's the idea that you have these generic types, or you have functions, things that can take generic types and then adapt based on the data type, and you'll have to kind of explicitly say, here's the type when you use it. So in this case, I'm creating an array of strings, so I put in brackets string. If I wanted to change one of them, do string away, string array, and then I can say 0 equals, so let's correct that. Up here you'll see I used 2 English words and then the number, so let's change it to the number 1. I can access it through with brackets, subscript. In this case I did 0. They are 0-based arrays like practically every other language out there. Not everyone, but practically every other language. But again, anytime you're learning a new language, this is another thing you always want to check. How do you deal with arrays? What's the initial subscript? Is it 1? Is it 0? There's also, you don't run into these a lot, honestly, at least not in Android development, but know it's out there. You can get some specialized array types, like int array is one that you'll see every now and then. It's just got some extra methods and features. And we call the helper function int array of. It's kind of weird. The syntax to me always felt weird on these. So now I've got an int array of 1 through 5. And again, this is just a specialized array. And then the other one that you'll see is a list, which is very, very similar to an array. You could do, instead of array of, list of. So I'm not going to type that out. What you'll actually use and what you'll see a lot more often is a list array. So we'll do string list array and equals array list of. And the big difference between an array list is I can say, see if it'll pop up for me, good. I can add values to it, whereas the other ones are static, I can't. So this one, again, it's just more common to be used. But know they're out there, and if you need them, you're aware that arrays and lists exist, you can go to kotlin.lang, or you can just go to Google and you can find lots of information. So I think I'll stop there. We're at the better part of an hour to cover some really basics that you probably already knew. So I'll stop there and we'll pick up the next part in the next video.